Hey all, so this is just a little recap of section 7.1 through 7.5. So we've now seen like a bunch of different methods of factoring, and as we run into them in the course of doing other math, it's not going to be in a section that's labeled, this kind we factor by grouping. You'll have to be able to recognize it, and likewise when you're taking the quiz or the exam, right, there's just going to be a bunch of problems on there and they're going to say factor. And so you're going to have to know how to do like all of the methods and then when to use which method. So this flow chart here is to kind of help you organize and strategize on how to get to the right method for the problem you're looking at. So step one, every factoring problem is look for greatest common factor and get it out of the way. Factor that out front. Unfortunately, if you miss that step, that probably means you missed the question on the test, because what you're left with is super hard, and that's where people will get stuck. So make sure and especially if the problem looks kind of extra hard, make sure there's not a greatest common factor that's the problem. Step two, count the number of terms, and it's either going to be 2, 3, or 4 terms. So you got your greatest common factor out if there's one of those, and now do you have 2 terms, 3 terms, or 4 terms? If you have 2 terms, there's really there are some greatest common factor problems, and I think I will have one of those in 7.6 to show you. I think I showed one in the last video as well, where maybe there's 2 terms and you just factor an x out front. But other than that, if it's 2 terms, it's going to be the difference of squares, where it ends up a plus b, a minus b. And so that's pretty much it for 2-term problems. If it's 4 terms, that's great. That was section 7.2. That's where I did the factor by grouping. So every 4-term problem, that's the way to factor it. And then it's the 3-term problems that we have 3 different methods, and then that's where it gets a little hard to tell them apart. Once you get the greatest common factor out of the way, if the leading coefficient is 1, in other words, if it starts off just plain x squared, then that means it's a 7.3 problem. You just do what multiplies to the end, adds to the middle, and write down the answer. And I'll do examples with all these in a second. So that's the best case scenario, it's that one. And actually this next one is also really easy if you spot it, and that is, are there perfect squares on both ends of the trinomial, in which case that's 7.5, the last section, and it's just the a minus b squared or a plus b squared. So if you spot that, it's really a super easy problem. The third one that was 7.4, and that's the one that kind of sucked, where we had to do AC method. And so that's when it leads with something that isn't 1 in front of the x squared, and it's also not a perfect square. So if it's not 1 and it's not perfect squares, that means you have to do AC. So that's your basic plan for all of these. 2 terms, difference of squares. 4 terms, grouping. 3 terms, then you kind of run down does it lead with a 1? Does it have perfect squares? No. Okay, then you're at AC method. So let me show you some examples. For this first one, that everything has a W means there's the greatest common factor. And until I get that out of the way, it's really hard to know what I'm working with. So let's take out a 2W and then see where that gets us. So W squared, and then this is going to be plus 10W, and 2 out of 18 would leave me a plus 9. Okay, cool. So it's got 3 terms. It leads with a 1, so that means it's the easy kind. So 2W, and I'll just set up my W in my parenthesis and my W in my parenthesis, and I can say what multiplies to be 9 adds to be 10. That'd be a plus 1 and a plus 9, and that's it. So that was the 5, what is that, 5.3. Leads with the 1, basically just figure out multiplies the end, adds to the middle, write down the answer. This has 2 terms, so we could have something like x squared minus 5x. So that would be the exception to the 2-term thing. That would be xx minus 5, where there's just a greatest common factor. Other than this case, if we see 2 terms, it's probably a difference of squares. This one also has a greatest common factor, which would be 5t. And that's going to leave me a t squared right there, and then taking 5 out of 45 would leave behind a minus 9. And then that is a difference of squares, and again, 2 terms kind of anticipate that. because that's our method. So this is going to be t plus 3, t minus 3. So that's our a plus b, a minus b. Okay, the next one is three terms. 4 and 25 have nothing in common, so there is no common factor. It does not lead with a 1, so it's not 5, 3, but it does have squares on the ends, so that makes it a 5, 5. And that's, again, if you can spot it, now it's super easy. It's just what times what makes 25y squared, so 5y. What times what makes 4? 2, it's a minus because of the middle, and squared, and that's it. If we want to check that middle, 5 times 2 would be 10, and then we double it, and that's the minus 20. So those ones are actually pretty easy, unless you don't notice the squares. This next one, no common factor, 3 and 7 doesn't play. It does not lead with 1, it does not have squares on the ends, so that means this is a 7, 4 where we have to do AC. So for that we do a times c, so 3 times negative 6 would be negative 18. And then we need two numbers that multiply to be negative 18 and add to be negative 7. So that sounds like a 2 and a negative 9. And they're 7 apart. And the big number gets the sign because the middle's negative. And then this is where we rewrite these terms. So we can go 3x squared plus 2x minus 9x minus 6. So from these two I could take out an x, and that leaves behind a, oops, I forgot my 3x plus 2. And then I need to get that sign flipped around so it's positive, so I'm going to factor out a negative 3. And that will leave me another 3x plus 2, because I'm factoring a negative out of a negative, so that makes it positive. I'll remind you here that these have to match for this method, and so if they're not matching, you've probably got a sign twisted up. I always, again, like to distribute back and make sure that my signs make sense, so negative times positive makes negative, negative times positive makes negative. So even if you're trying to factor that out and you're questioning which thing it should be, try writing this one down, right, and distributing and seeing if that makes it come out true. Pretty common error I see on exams. So from here we factor that common factor out front, so 3x plus 2, and then leaves behind the x and the minus 3. So for three terms again, we have where we end up with a 1 in front, which is great. Then we just multiplies the end, adds to middle, write down the numbers. If we see squares on the ends, that one's great, because then we just basically write down the a plus b or a minus b quantity squared. If both of those things fail, then that's where we have AC method. And then our last one here, we got 4 terms, so that means it's got to be 5.2 in grouping. And oops, let me undo that. So from those first two, I can factor out w squared, leaving w plus 3. For the next two, I can factor out, I want this to be positive in the parentheses, so I'll factor out a negative 7. And then another w plus 3. Again, if you're questioning your signs, just distribute and go, yeah, that makes negative 21. W plus 3 out front, and w squared minus 7 is what's left behind. So 2 terms, 3 terms, 4 terms. 2s and 4s, pretty straightforward because there's only one thing they could be. The 3 terms, that's where you kind of have to get where you can distinguish between those 3 styles so that you're using the right method.